All right, we're going to run through our CFA from 3.9 to 3.11, dealing with percents and looking at the different kind of percents problems we could have and different ways to solve them. We won't show all the ways. We'll talk maybe about a couple of different ways that we could solve some of these. All right, so it says we can use equivalent fractions or any other method you choose. So I'm going to start with a different method before I do the equivalent fractions. I want to know 75% of 90, and we know of means multiply. Okay, and a lot of you have figured this out. You like these types of problems because you just know I want a percentage of, and my answer should get smaller. And of means times, and the only thing we learned was in this way, 75% is 75 out of 100, or 75 hundredths. So I can just write it as a decimal, and 75 hundredths times 90. And if you do 75 hundredths times 90, you'll get 67.5. Okay, and a lot of you like that way. When you figured out it was an of a certain out of 90, you could just multiply. And it makes sense. My answer should be smaller than 90 because I just want 75 hundredths of it, or 75%. So my answer went down. So this would be one way to solve it. Another way, if you set up these equivalent fractions, we know 75% means 75 out of 100. Percent means out of 100, so I could just write it that way. Now, I don't want to get it out of 100. This says I want out of 90. So I have to somehow get my denominator to a 90 to get this to work. Okay, so how do I get 100 to 90? I could do it and divide it by a fractional number, but we also learned, can I change this into a form where it can be easy to get this bottom number to 90? And what we learned, if we turn and divide this, one way to do this, I could divide them both by 10. And I'm going to go write it over here, but that would change this to 7.5 out of 10. Okay, if I made them both 10 times smaller, that means 7.5 out of 10. And the reason I got it to 10 is because 10 can easily get to 90. All I need to do is take this times 9, and now I get it to 90. So do this 9 times. So I'm going to do 7.5 9 times. And if you take 7.5 times 9, you will also get 67.5, which would then be my answer because it's out of 90. 75% of 90 would be 67.5. So there's one way to set up a proportion or to use equivalent fractions to solve that one. Okay. Second one here, 65 is 65% of what number? Some of you guys are making this harder than this problem is. 65% means 65 out of 100. Every time I see 65%, I should be thinking that's 65 out of 100. So 65 is 65% of what number? Well, all I have to do is look at the denominator. Okay, the answer is 100. 65 is 65% of 100 because it's out of 100. I don't have to do any work there. My answer is just 100 if I understand percents. Okay, second one here, 70% of 210 is what number? Again, this is this of, so I can say 70% is 70 hundredths, or I can just say 0.7. 70 hundredths is the same as 7 tenths, so 0.7 times 210, because we know of means multiply. If I take 0.7 times 210, I'll get 147. I know my answer should go down from 210 because I just want 70% of it, so that would make sense. Again, I could have done the proportion like I did here and got it out of 10. That would work as well, but in this case, I'm just going to show the one way, and the answer comes up 147 here. So make sure you have these written down. These are all similar problems, these two here with these of problems out of 210 and out of 90 on the first one there. So again, making sure you have this stuff written down. We'll go ahead and look at a different type of a percent problem here in a second. And again, we'll pause the video if we need to while you guys are writing these things down. And if you have any other questions, we'll talk about them here before we move to the next when we're going through this. Okay, so make sure you're getting these written down. All right, let's go look at number 2 here. All right, so number 2, Gavin withdraws $225 from his bank account. This amount is 15% of his total savings. So how much did he have in his account originally? Okay, so these sometimes give kids some trouble, so it's a different type of problem. In this one, we know Gavin withdraws $225 from his bank account. So let's do the equivalent fraction first. If I had $225 out of his total, I don't know his total right now, equals 15% of his money. So it's 15% means 15 out of 100. So 15% means $15 out of $100, or whatever has to be comparable to 225 out of what? Because we know 15% is 15 out of every 100. And well, we know he took out 225, and we're missing his total right here. So sometimes put a question mark here. You can put a variable there for t. So what's the total? That's what I'm missing. So all I need to figure out is, in this case, what this bottom number is. What am I doing to the 15 multiplicatively to get it to 225? Because we know ratios are multiplicative. So to figure out how to get 15 times what gets me there, can I just divide these two? And if I take 225 divided by 15 to tell me how many times smaller it is, it actually gets 15. Because 15 times 15 is 225. So what they're basically doing here, if to get this down to this 15, I need to divide this by 15. So that means I would also have to divide whatever this is by 15. But if I'm going this way, remember, now I need, these are 15 times smaller. So I multiply by 15 going this way. Because if I took 15 times 15, it would get me back to 225. So 100 times 15 is $1,500. Okay, so how much was in his account originally? This makes sense. He's got $1,500. He took out 225 out of 1,500, which is 15 out of every 100, or 15% in this case of his total savings. Okay, that way it can be a little more confusing sometimes. Another way to think about this is, I like to write it like this. I know 225 is means equals, is 15% of his total savings. All right, so that is 15%. I know I'm trying to get back to his total account, which would be 100%. So how do I get from 15% to 100% multiplicatively? I can just divide these two and it would tell me. Now, it would be a fraction or a decimal. So another way we talked about doing this is get these into a form that matches up better, like that'll get to 100 multiplicatively with a whole number. So what if I divided this by 3? Because if I take 15% divided by 3, it gets me down to 5%. And then I know 5 can get to 100 by multiplying by 20. So if I divide this by 3, this side I must divide by 3. Okay, and if I take 225 divided by 3, you'll get 75. So that tells me is 5% is $75 because 15% was 225. So now I can easily get this to 100% by taking this times 20. So I do that 20 times, so I know I must do this 20 times. So if I take 75 times 20, you will get 1,500. So 100% of his money is $1,500. Again, you can try and do it with this proportion, okay, with these equivalent ratios, or you can try and set it up like this where 225 is or equals 15%, we'll get it to 100%, okay, in a form that matches up. So that's another way to think about it. Again, these can be complex. You really got to wrap your brain around what they're asking for. These are tough problems, okay. Number 3 is similar, so we'll go ahead and work through number 3 here. Chocolate chip ice cream is 20% chocolate chips. Zach wants to eat 4 cups of ice cream, so how many chocolate chips will he eat? Okay, so we know chocolate chip ice cream is 20%. Okay, so 20% I know means 20 out of 100. And since we're dealing with cups here, that means 20 cups out of every 100 cups are chocolate chip. But Zach wants to eat 4 cups. So I'm thinking about that way. I've got to get these 100 cups. I'm only going down to out of 4 cups of total ice cream. This is the chocolate chip, 20% out of the total, or 100% of the ice cream. But I want to get it down to 4 cups, not 100 cups. He's not eating 100 cups. So how much would be chocolate chips? And I see the relationship here that if I divide this by 25, because I know 4 quarters equals 100, so I know this can divide by 25. I need to go 25 times smaller, which would be 4. So I must do 25 times smaller here. And people sometimes get confused. You got that 20 divided by 25. It'll be a decimal. But guys, we can also write it like a fraction. Okay, 20 divided by 25, just written like a fraction, is that. Now I know it looks weird in this complex fraction, but 20 25ths is my answer here. This is the chocolate chips. Now some people could get that to simplest form. I know they both divide by the greatest common factor of 5, and it changes to 4/5. Okay, so how many chocolate chips will he eat? 4/5 of a cup. We know these are in cups. So how many chocolate chips? 4/5 of a cup. Some might also just take 20 divided by 25 on a calculator, or 4 divided by 5. Remember, that'll take it to a decimal, so it could be 0.8 if you do that. 4/5, remember, is 80%, okay, or 8/10 of a cup in this case. Both these answers would be equivalent. They're the same thing, but he would be eating 4/5 of a cup of chocolate chips if he ate that ice cream where 20% of it was chocolate chips. And so making sure you have all these copied down and identifying the difference between these types of problems and how to solve those.